Welcome back, grade 12s. This is part 3, which is the last video on these calculations. So we are now going to see how to calculate the percentage purity on these electrolytic cells. So in part 1, we saw how to calculate the average current. In part 2, we saw how to calculate the mass. Now in part 3, we will see how to calculate the percentage purity. So I'm going to do 2 questions on this video. So I want you now to follow along. There is a question in front of me, which is question 9. So the question says, the statement says, the simplified diagram below represents an electrochemical cell used for the purification of copper. So this is the cell. If you look at electrode B, we have the impure copper. We know this is the anode. Then on electrode A, there will be a purified copper. Then inside there's an electrolyte. So they said after the purification of the impure copper was completed, it was found that 2,85 times 10 to the power negative 2 moles of copper were formed. The initial mass of electrode B was 2 grams. In other words, the mass of this impure copper was 2 grams. Now, they said now, calculate the percentage of copper that was initially present in electrode B. So the percentage purity, the percentage of copper that was initially present in electrode B is the percentage purity of copper. So we're going to now have to use the formula of the percentage purity to find the percentage of copper that was initially present in electrode B. So let us check what we have here. They said now after the purification of impure copper was completed, it was found that 2,85 moles of copper were formed. So we do have the number of moles of copper that were formed. Okay, so if on this side, look at electrode B, we have the impure copper, and we know this is the anode because always we put the impure copper on the anode. Now on electrode A, there will be the pure copper here. There will be the pure copper after the process, and we know this is the cathode. So if we want to find the percentage of the copper that was initially present in electrode B, the purification of this, the formula of the percentage purity says percentage purity is equals to the mass of the pure divided by the mass of the impure substance. Multiply that by 100%. Yeah, so this is a formula that we are going to use to find the percentage. Remember, this impure copper will deposit in the solution these ions, and electrons will be given off to the cathode. When cathode receives these 2 electrons and receives this copper 2 plus, it will become, when the 2 Cu2 plus ions react with those electrons, it will become the pure copper. On the anode, we said this copper donates the electrons and is oxidized to 2 plus. And those 2 plus ions are reduced to become the copper solid form. The pure, this is the pure copper, this is the impure copper. So we want to find now the percentage purity here. So what we have the number of moles of this. They said it is 2,85 times 10 to the power negative 2 moles. So on this other side we only have the mass. So in order for us to find the percentage purity, therefore we need to find the mass of the pure. In other words, we need to find the mass of this one, the mass of that one. We have the number of moles, so we can find the mass if we have the number of moles. Then this will be our numerator. Then the mass of the impure, we already have, they said is 2 grams, so we already have this one, 2 grams. We need to find now the mass of the pure. Here is the number of moles, here is the number of moles. So let's quickly do this one. Okay, so let me quickly do here the mass of the pure. This is the mass of the pure is equals to the number of moles multiplied by the molar mass. Remember, here we are dealing with the copper, and on the periodic table, copper we said is 63,5 grams per mole. That is the molar mass of the copper. So the number of moles they gave us to be 2,85 times 10 to the power minus 2. So this is 2,85 times 10 to the power negative 2 multiplied by 63,5. So let's find quickly what is the mass of the pure. So the mass of the pure will be 2,85 exponent negative 2, multiply that by 63,5. So we get the mass of 1,80975 grams. So I'm going to substitute that value here, 1,80975 grams. Then I'm going to divide it by 2. Then I'm going to multiply it by 100. So I get 90,49. 90,49%. So this is now the percentage purity of the copper. Yeah, so this is how you calculate the percentage purity. That means if it was initially 2 grams, this is how much that was used from that 2 grams, which means it is 90,49% of what was used from the 2 grams. So this is just a simple calculation. I think it was around 4 marks. Yeah, so we are done with this one. Let me do the second question, which is also similar to this one. Okay, let's look at this one. This is the second question. It's also a percentage purity question. A learner sets up an electrolytic cell represented in the diagram below to purify copper, which contains platinum and silver impurities. So this is the impure copper on the anode, the pure copper on the cathode. During the purification of 28 grams of impure copper, 0,8 moles of electrons were transferred from the anode to the cathode. Right there, we need to write this down. The impure copper is 28 grams. So the mass here is 28 grams. 0.8 moles of electrons. 0.8 moles of electrons were transferred. In other words, the number of moles of electrons were transferred, which was 0.8 moles. These are the number of moles of the electrons, but we don't know the mass. We don't know the number of moles. We don't know the number of moles of the pure copper. And we don't know the mass of the pure copper. We just know the number of moles of the electrons. So we need to be careful there. So calculate the number of copper atoms formed at the cathode. So for 3 marks, the number of atoms of the copper. Remember, this reaction of the copper. Let me first do the oxidation reaction. At the cathode is the reduction reaction. This is the reaction on the cathode. Now, this is the reaction on the anode. There is oxidation on this side. There is a reduction on the cathode. There is oxidation here. There is a reduction here. That means that this impure copper will deposit the copper ions in the solution, and they will be attracted to the cathode, and electrons will be oxidized that way. Then they will be reduced this side, and this will be reduced, the copper ion from the solution, and the electrons will form the pure copper. This is the impure copper. So the only thing that we know is this one. We know the number of moles of this is 0.8. But now they are saying to us, also we know the mass here. The mass of this we know to be 28 grams. So now they are saying, now calculate the number of copper atoms formed at the cathode. So we want to know how many are these, the number of these electrons formed at the copper. We only know the number of moles. We need to know the number of electrons formed. Okay, sorry, I think I wrote the statement incorrectly. The statement says the number of copper atoms. Okay, sorry, my bad. So not the number of electrons, the number of, let me erase this, the number of atoms formed. We want the number of these ones. Number of copper atoms. Yeah, we just have the number of moles of the electrons. Now we want to find the number of copper atoms. I didn't say that one. Okay, so I'm gonna quickly do this calculation on a white page. Okay, this is what we have. This is the half reaction. So we have the number of moles of the electron. This is the number of mole of the electron. Let me be clear here. This is the number of moles of the electron. So what is the number of mole of the copper atom if we know the number of moles of the electron? Check first what is the ratio. The ratio is 2:1. 2:1. So that means if we have the number of moles here to be 0.8, then this one copper will be half of that one. So that means that if we divide this by 2 and we divide on the right by 2, then we're going to have 1:half. So if this one is 0.8, then we multiply also that side by 0.8. So 0.8 divided by 2, I think it's going to be 0.4 mole. So that means that the number of moles of the copper atom is 0.4 for mole. Yeah, so then if we want to find the number of atoms, the number of atoms is the same formula as the number of particles or the number of electrons. It is equal to the number of moles of atoms multiplied by the Avogadro's number. Okay, I need space here. Let me do it below here. Yeah, so let me write it here. Remember that formula, the formula that says number of moles is equal to the number of particles or electrons or atoms. They all means the same thing, so they can be used, like if you want the number of particles or number of electrons or number of atoms, you still use the same formula. Divide by the Avogadro's number. So in this case, we are looking for the number of atoms, but you still use the same formula. We must know now the number of moles of the atoms if we want the number of atoms. If we want the number of electrons, we must know the number of moles of the electrons. Yeah, simply as that. So we know the number of moles of the copper atom is 0.4. So we want to find the number of atoms. Then we're going to divide by the Avogadro's number, which is 6.022 times 10 to the power 23. This is over 1. So we're going to cross multiply here. We're going to cross multiply. Then we find the number of atoms. Okay. This 0.4 is over 1. So we're going to cross multiply. Then we're going to say the number of atoms of copper is equals to 0.4 multiplied by 6.022 times 10 to the power 23. Then we need now to find this on the calculator. 0.4 multiply by 6.022 exponent 23. Then the answer is 2.4088. 2.4088 times 10 to the power 23 atoms. So this is the number of atoms of the copper. Yeah, that was question number 1. I think it's very clear. So let's look now at the following question. Now, they are saying now the copper used for electrical wiring and cables must be 99.99% pure. Determine by calculation whether the impure copper sample is suitable for use in electrical wiring and cables. Assume that all copper at anode has reacted. Okay, so this is the percentage purity question. We need to calculate percentage purity of this, and it must be 99.99. If it is below, then we know it's not suitable. But if it is 99 or 100, then it is suitable. So let me show you how to do this one. Okay, look at this. So on the anode, we have the mass of the impure. Then on the cathode, we have the mass of the pure. But we do have the mass of the impure is 28. We need to find the mass of this now, the mass of the pure. Why? Because percentage purity says the mass of the pure divided by the mass of the impure multiplied by 100. So we already have the mass of the impure is 28 grams. So we need now the mass of the pure. We need this mass of the pure, which is this one. So what we know the number of moles here. They told us to be 0, the number of moles of the electron is 0,8 grams. We did find the number of moles of the pure. We said since the ratio is 2 is to 1, then that means the number of moles of the copper atom is half the number of moles of the electron. We find it to be 0,4 mole. So if we know the number of moles of that copper atom, we can find now the mass, because we do have the number of moles. The number of moles is 0,4. The molar mass of copper 63,5. So you can multiply the 2 here to get the mass. Let's multiply that. 0,4 multiplied by 63,5. 25,4. So the mass is 25,4 grams. Okay, let me quickly redo it here. So we did now manage to find the mass of the pure. Remember, we had the number of moles of the electron. We equated it with the number of moles of the copper atom. Because of this is 1 or half of that one, so we divide 0,8 by 2 to get 0,4. Then we use this formula to get the mass. We said the number of moles, which is 0,4, multiplied by the molar mass, which is 63,5. It gave us 25,4 grams. So we're going to take now this mass, which is the mass now of the pure, 25,4 grams, divide by the mass of the impure, which was this one, that they gave us 28 grams, multiply that by 100%. So when you calculate that, 25,4 divide by 28 multiplied by 100, I got 90,71. I got 90,71% pure. So the question was asking, the copper used for electrical wiring and cables must be 99,99% pure. It must be 99,99 pure. Determined by calculation whether the impure copper sample is suitable for the use in electrical wiring and cable. So we get 90,71, which is below. So 90,71% is less than 99,99. So that means that it's not going to be suitable for use in electrical wiring. Yeah, so this is the answer for this question. Otherwise, this is the end of it. So I hope by now you have the idea of how to calculate the percentage purity. You just have to know the mass of the pure, divide by the mass of the impure, then you multiply it by 100. Yeah, so this is the end of part 3.